Welcome to Knowledge Platform. Today our topic is electric current. For more videos, subscribe our channel. Thank you. Electric current is the rate of charge flow past a given point in an electric circuit measured in coulombs per second, which is named amperes. In most DC electric circuits, it can be assumed that the resistance to current flow is a constant so that current in the circuit is related to voltage and resistance by Ohm's law. The standard abbreviations for the units are 1 ampere is equal to 1 coulomb per 1 second. Electric current. This diagram shows electric current flowing through resistor on which a voltage V is applied. So Ohm's law says that I is equal to V over R, as you can see in first diagram. Second diagram is right hand rule. Now see this rule. The magnetic field made by a current in a straight wire curls around the wire in a ring. You can find it by pointing your right thumb in the direction of current in the wire and curling your fingers. Your fingers will be curled in the same direction as the magnetic field around the wire. It turns out that you can do opposite of this rule to figure out the direction of the current in a wire if you already know the direction of magnetic field. And in third direction you can see that a force F is applied on a current carrying wire if it is placed in a magnetic field. This force is equal to ILB sine theta, where theta is equal to 90 degree. Now we explain the conventional electric current. Although it is electrons which are the mobile charge carriers which are responsible for electric current in conductors such as wires, it has long been the convention to take the direction of electric current as if it were the positive charges which are moving. Some texts reverse the convention and take electric current direction as the direction of electrons move, an obviously more physically realistic direction, but the vast majority of references use the conventional current direction, and the convention will be followed in most of this material. In common applications, such as determining the direction of force on current carrying wire, treating current as positive charge motion or negative charge motion gives identical results. Besides the advantage of agreeing in direction with most texts, the conventional current direction is the direction from high voltage to the low voltage. Similarly, high energy to low energy, and thus some appeal in its parallel to flow of water from high pressure to low pressure. Thanks for watching our videos. Subscribe for more videos and press bell icon for our